Welcome. So the next part yachatarisa futhi again is types bases at now. So first of all we have what are called metal oxides, and it so metal oxides, let's say for example we may have maybe for example we have magnesium oxide, right? So magnesium oxide yedu it acts as a base, because magnesium oxide yedu let's say we are preparing these things that are called metal hydroxides, which are bases as well. When we are preparing metal hydroxides, we not dissolve a metallic oxide in water. In other words, tinenge tichiti magnesium oxide plus plus H2O, and then this would give us it would give us the magnesium hydroxide, and the magnesium hydroxide yedu. So take note especially on this one, number one metal oxides, and number two of metal hydroxides. These are merely the same. So if a metal oxide or a metal hydroxide reacts with an acid, the reaction would still be the same, and it will give us a salt and a water. For example, if magnesium oxide reacts with with hydrochloric acid, and it would give you it would give you magnesium chloride, plus it would also give you H2O, because it will be a neutralization reaction. So that's what it will give you, and it can asichiyazosiyana manje pa reactor a metal oxide nepa reactor a metal hydroxide. Chinenge zvangosiyana, it's per balancing of equations. But anyways, in an balancer equation I just showed you kuti zvinofamba sei, and it can remember metal oxides, they react the same way as metal hydroxides, and it can, but uchazonotisa kuti kana takutarisa issue yereactivity uchazonotisa kuti pane zvimwe zvinhu zvinenge zvakazosiyana that come into play in terms of speed of reactions, etc. But that's not my focus on this topic, and my focus is on how they react with with the acids, and it can. So metal oxides anoreacta nema acids edu achitiburisira a salt in water. Metal hydroxide, they do the same. And then we go to the third one, which is carbonates. So carbonates now, they do something that is different, a little bit different from metal oxides nema metal hydroxides. So carbonates edu rather than just reacting achiburitsa a salt in water, what they do is that they would react and they would produce you something like you have carbon dioxide plus water plus also a salt. That is the only difference that we have when we use carbonates, and it. So I would want to do maybe one example, because carbonates either any CO32 minus iron, and it I just want to do one example yekuti ukwanise kunotisa kuti zvinombonyasofamba sei. So panapa I will use calcium carbonate. Remember, calcium is in group 2 and carbonate inobaka 2 minus, the formula will be CaCO3, and it indicate EO plus HCl acid yedu. So what it would do is that calcium yedu reactor with the chlorine part of that formula calcium chloride, but calcium chloride yedu, that will be this one, and it, because calcium is in group number 2. But after I format this one is what we call a salt, right? Then it would also have to form water, to this water, which is H2O, and also form the other part, which is carbon dioxide, which is CO2. So then after had all of this, the only remaining thing, it would be you would have to balance the whole of this equation, and it. So remember, carbonates edu, because they have this the carbonate ion, they will form carbon dioxide plus water, and also the salt. So to round up on the type of bases that are there, the metal oxides, the metal hydroxides, they form what? Salt plus water. Then a carbonate, it forms carbon dioxide, water, as well as what? As well as a salt. And we also have my other bases, for example, ammonia. Ammonia can also react as a base and it forms a what? A salt, and even water. And sometimes it forms a salt, but then my reactions achona anenge asina water inenge chibuda. So for you urungoita chete metal oxide, metal hydroxide, nemetal nema carbonates or metal carbonates. That will be the stipulation for your syllabus.